Okay, let's get going. Well, welcome everybody to the Society of Cost Engineers webinar with our featured speaker. I'll introduce Fritz in just a minute. My name is Gary Kokens. I'm a member of the Society of Cost Engineers. So the Society is an association of cost engineers. Obviously, that's in its name. The website will be in the slides you'll be getting, or you can just do a search, Society of Cost Engineers. Membership is free. It's an association for collaboration and learning. Myself, Gary Kokens, I'm an undergraduate from Cornell University, Industrial Engineering and Operations Research, 71, got my MBA from Northwestern University, Kellogg in 1974. First 10 years, FMC Link Belt, then 7 years with Deloitte Consulting, then KPMG Consulting, then 16 years with SAS, the large analytic software vendor, native of Chicago, go Cubs, go Bears, 74 years old if you're doing the math, but I feel like 44. But enough about me. Fritz, I'm going to have him pronounce his last name because I'm an American and can't pronounce German names or Swiss names. But the bio on Fritz is he is an accomplished thought leader in the digital and IT space with more than 30 years of relevant experience. Fritz has domain expertise in the design and business architecture of award-winning Industry 4.0 digitization projects that embrace IoT, Internet of Things, artificial intelligence, and cyber physical systems. His passion is enabling clients to master the art of digital transformation through organizational capability building in cost prediction in the technology domain across Europe, Africa, Asia, and Australia. Title of his talk is Embracing the Opportunities of Artificial Intelligence in Cost Estimation. So Fritz, I'm handing it off to you and your last name.
Yes, absolutely. Thank you, Gary, for this warm welcome and introduction. So my name is Fritz Wüthrich. It's a Swiss name, actually, and I don't expect anyone to pronounce my name. So if you call me Fritz in the interaction, that's perfectly fine. So before we actually go into the presentation, I want to briefly announce that we'll have a poll at the start, a poll with a question, which I would extremely value if you attend to at this very moment. And after that, we will, or during the presentation, we'll have the opportunity for you to ask questions. We have a Q&A facility during the presentation. We'll attend to those questions at the end of the presentation. It may well be, if there are a lot of questions, that we will respond to those questions after the session. So don't be disappointed if we don't exactly attend to your specific questions during today's session. So we'll wait a moment before we kickstart. And thanks for attending to the question. So an interesting data point in the context of this session today, McKinsey has recently published a paper where they're articulating, after some research, that engineering-heavy organizations will significantly benefit to the extent of 20% through the adoption of AI enablement in the estimation, but also engineering value stream, which I think is a significant value that AI can bring even to mankind, not just the individual companies, but it will be of significant value. And let's see what kind of use cases we can discuss today. Okay, great. So let's kickstart. I mentioned the Q&A. I'm very much looking forward to engage after the presentation with you. So the brief storyline is very straightforward. Why AI matters to you. I will briefly look at the rising trends in cost engineering and related topics. We'll look at the background of AI. How did we come about the situation right now? And where do we stand in the journey? What's the journey ahead of us, most likely? What are the challenges and limitations of AI today? To what do we need to attend to, and where do we need to be careful and keep our human, generally intelligent mind very much switched on? But then the opportunities to grasp, right? I'll show you a few cases that are very practical. Some of them are related to tools and products, some of which will also be a bit more forward-looking. We'll have significant development in the year ahead of us. And then we'll close with some thought-provoking citations from leading historians, and we'll close with how you can take specifically yourself advantage tomorrow. Okay, so let's get into this. So the rising trends for cost estimation. Who would have expected artificial intelligence take spot number one? And AI in this context has multiple aspects of relevance. One aspect is the estimation for AI and its impact. So AI, can impact the benefits from operation. Basically, AI can drive operations, and estimating with AI, basically the conversation that we have today. Digital twins. Digital twins are a logical representation of the reality, either the planned reality or the as-is reality. And, these realities represented through digital twins can change through an AR, VR kind of design process. And integrating cost estimation with these design data will actually be a great real-time cost estimation adjustment, right? Leveraging data-driven decision-making, a very important element, which is at the core of cost estimation and cost engineering, because that complex data will actually give predictive scenarios and enable your consumers of cost estimation to take good decisions based on the predictable and reliable data that you prepare. Advanced risk analysis and management techniques. A risk is complex, and risk has become even more complex with geopolitical challenges, but also supply chain disruptions that we have seen in the recent past during COVID, for example. And factoring those into the cost estimation will be an important element in the future. Some organizations have already tapped that, but I think the complexity need to be understood even deeper, and how that relates to modeling cost estimations in the future. Green and ESG in as a wider term, environmental, social, and governance, will play a significant, important role. For some organization, it's already the core of the business, because they are, for example, engineering eco-fuels and the requisite technologies. But whatever decisions are made in engineering and cost engineering will in the future be able to equally to the cost footprint describe the eco footprint, for example, the carbon footprint related to the manufacturing of a particular part, for example. So this is not the only aspect of relevance. The other aspect is we have an ever increasing complexity and need for speed, basically. So the product life cycles become shorter, particularly in the technology space, and coping with these accelerated speed in the product release and product engineering side, cost estimation need to cope with it, right? And getting AI to help with the speed element will be of significant advantage to cost engineers. So let's quickly look at the background, and I'll keep this rather short, but I want to contrast a few things. So in a nutshell, right, the consumer space has become very much aware of AI, a little bit in gaming over the last 10 years, but more recently over the last 2 or 3 years through the generative AI capabilities, as you can see the representation here in this little picture here. But this is not a very recent development. The development actually started 2,400 years ago through the ancient Greeks, where they have developed mechanics to predict astronomical constellations. And of course, the medieval kind of made almost every innovation impossible, which again picked up in the 1950 with Turing. You know, the Turing test, for example, which says, you know, a system is artificially intelligent if a particular stated question cannot be, the result or the answer to the question cannot be differentiated by a judge whether it comes from a machine or a human, right? There were some more developments, which I'm sure some of you have read about or even experienced. And, you know, AI has made a few headlines in the news also, right? So on the positive side, we've seen Da Vinci, which is a surgical robot. It actually has more than a dozen AI systems embedded. It has analytical systems embedded. It has image analytics embedded. It has operational, mechanical, control related AI systems embedded. And its surgery is extremely exciting, excitingly precise. But we've also seen some downsides. In 2010, Microsoft has proven to be ethically biased in image search, which of course countermeasures has been taken, and the governance of the data and AI systems has been increased. And in 2018, around this time, you know, the first casualty unfortunately happened in Arizona with a self-driving car that could not detect that a woman pushing a bicycle over a 4-lane street was actually a situation to decelerate or even put the brakes down. On the aspect of myths and misconceptions, I think some of those are quite prevalent still in society. And I think it's important to look at those and you know, drive the conversations then in the relevant direction. So AI can't feel, right? Doesn't have emotions like human. It can detect emotions and it can mimic responses, but those are not yet at the level that we see that humans have, right? AI systems are fallible very clearly because they were trained on human provided data. They were basically developed with AI models that were applied to the data developed by humans. It's very clear AI is still fallible. So how does AI work conceptually speaking? So at the core of it is data. This little box that you see to the top left of this blue background, you know, should actually proportionally take the entire screen, because data is actually the oil of the AI engine. And you know, and the model that is developed with the development of code to actually use the model is actually the drill to take the oil out and make it usable. So the data and the model are almost like the two legs of a human body. The right model need to be applied to the data. And there are also indicators that clearly from which you can derive whether a model is fit for purpose or not. And you know, AI developers are basically at the core of these three areas. Data engineers work on the data, and AI developers basically create a model and a code, which then lead to learning and inferences, either through automated learning with operational AI that drives actions, or presented data to humans where we can use the data and drive our inferences for corresponding decision making. So in the larger picture, where do we stand, right? So at the bottom of the slide, you see AI at the core and techniques and enabling technologies at the center and bottom of it, right? For example, you see neural networks that make image analytics possible. We see machine learning that make predictive analytics possible, right? And today, we basically use these applications. We use these applications to do particular jobs. As I mentioned before, autonomous driving car, or different tools that we use for image editing, creating natural language, generated text, etc. But we'll see a journey ahead. We'll see artificially general intelligence around 2050, 2060, depending on the development of the technology and the data. But that is basically envisioned to be on par with human capabilities, and we refer to it as human generally intelligent, in contrast to AGI, and the two would actually almost work in tandem at par. And there's a long shot of a vision, which is artificial super intelligence, which would be far more advanced than humans are at this moment. And this is more visionary, but I'm led to believe that this takes significant more compute power and data processing ability. So we are still at the beginning of that journey, and it's actually us, it's you, me, and society to harness the everything that AI presents to us and make it very useful for humans and the nature, basically. Okay, okay, great. So challenges and limitations of AI today. So this is a long list, and I won't go into depth of each one of them, but the most prevalent and most important ones are data availability, for example. Data availability is not so much a challenge when we talk about generative AI that we see in the public domain through Google's Gemini, for example, or OpenAI's ChatGPT. Based on the simple fact that these systems are trained on languages, on texts. So 1.5 trillion of words have been fed into these systems to, be what they are today. But the situation is different when you look at expert systems. So in contrast to ChatGPT, which is based on a large language model, expert systems are called small language model or expert language models, which basically represent a particular domain of a function, an expert function, which has data related to a particular product or a project, right? And preparing data of similar projects or products is something that cost engineers will need to take care of to benefit from AI in the cost estimation function in the future. But it's also important to recognize that generative AI is not best at maths, right? Generative AI has been trained at natural language processing, and as such, it understands language and can articulate language. But using AI for preparing numbers for calculations and give a particular meaning to a particular data entity or a complete data set, that is still outside of generative AI, and it will be the challenge to bring the two together, the best of breed, basically the expert system, AI, and the large language model. But there are other topics that you have probably seen discussed in the public domain, which is bias and fairness. All these topics are addressed as we go, and there are also organizations, startups, for example, that that are pitching in this field to build, credible AI capabilities. So at the core, for example, we see cloud environments that are catered to a particular geography that cannot be hampered outside the country. But we also see the first steps into the traceability of how AI drives conclusions. For example, Google's Gemini is actually presenting the source from which it fetched certain data when you interrogate Gemini today. So I'll talk through a few of the opportunities that you can actually grasp in the future. But let me first quickly draw your attention to the graphic at the bottom. So GitHub is a development platform owned by Microsoft, and there was a comparison study that was done. People who used GitHub Copilot versus developers who did not use GitHub Copilot. Those who used it were about double as fast as the others, or 55% less time for the same development job given to them. So it's a matter of productivity at first sight, but it's also very clear, a mediocre or bad developer will not become a great developer through AI. That's very clear. But a good developer can become a productive or fast developer by employing AI facilities. So let me now dig into or go through the different use cases that we're seeing. So number one, the estimation for development for AI technology and machine learning operations. So AI technology can be electronics, embedded systems, embedded software, but it can also be, computer-hosted software on open systems, etc., internet-based systems. So the entire estimation for these is, of course, an important capability to have in the future. The second element is the AI development. So the second part is the estimation of the impact from AI development and its operations. For example, one case I've given here, right? How can AI make a difference to a development team, or AI ops, for example, which are hyper automation capabilities, for example, in IT, that can actually drive operations down to the level of 30-40%, even lower in some cases, versus previous mode of operations before AI adoption. Then a third use case is quite straightforward, using AI as an estimation assistant. Quite often, the systems that you use and the estimation work that you're doing has a lot of bespoke knowledge, bespoke engineering expertise at the core, but also model details and parameters which are sophisticated to research if you don't know it on top of your mind, and sometimes those are more libraries than just books in terms of quantity of information. So an estimation assistant can be quite handy. Then the fourth one is the evaluation of a primary manufacturing process based on image analytics of parts. Fifth one is the intelligent inference from existing data and existing models. And the last one with which I want to close is bridging the knowledge gap. Bridging the knowledge gap has, to an extent, some demographic root causes, but also the change in how the proficiencies are structured. So cost engineers in the past have been quite often people from the shop floor who made their career into the office and had passion with numbers. Whereas today, more often, you find cost engineers are people who pursue a white-collar career, a business degree, a financial degree or number-specific degree, where the shop floor experience is actually missing. So I believe there is a significant opportunity to fill in here. Now, let's start with the first one. We'll dig into that number 3 estimation assistant with the next slide. But at the core of it is prompt engineering, right? Prompt engineering is a discipline quite often advertised on the internet with, with the next big skill to have. But at the core is simply a skill to be able to ask questions that are as comprehensive and rich as you would instruct an apprentice, right? So the question of the style, the question of the role that you assign to the AI in your Q&A kind of interaction, in your prompting, is very important. But also ask what kind of output format you're looking for. So you could also ask AI to ask a few questions as data inputs before AI comes back with the answers. And certainly refining the prompt is very important to do until you receive your desired quality of an answer. Now, the estimation assistant we have at Galorath tested and developed based on ChatGPT. It's the version of the OpenAI assistant that ChatGPT provides. We've been training the system with the libraries of documents that we have, and we've integrated it with our estimation engine in order for it to respond not only with theoretical questions like this one, how do I estimate an Internet of Things device, which would naturally be written in a book or a document. But we've also then, in this second screenshot, asked prompts where we expected very clear answers, subject matter related answers, with a clear format, clear data, and well, we got it actually, right? So what we have done is we have basically provisioned the OpenAI assistant, which is a private version of a ChatGPT, which is at the back still hooked up with the large language model GPT. And once you query it, it actually interprets the language that you're asking with the large language model. And then it subqueries the expert system at the core and comes back with the query result. That is at a high level how such a concept works, and training such systems is possible. It's even possible with your own data, with your own numbers, with your own documents. That is something that is quite possible in the near future, and we'll be happy to discuss more details on that particular front. The next one is AI image analytics, right? Why AI image analytics? And you see 3 image previews of files that were used as a training data set for a TensorFlow based model programming. What's the value behind this, right? The value is very simple. When an cost engineer today works on the estimation exercise, typically what he gets is a step file, is a CAD file basically, that has the polygonal information about the 3D model. But as a first step, a cost engineer has to decide which primary manufacturing process do I employ and what is the cost related to manufacturing this particular piece. Now, what we're looking at as a use case here is training a system to the extent that it can automatically determine the best fit for purpose primary manufacturing process based on what the system sees, right? Based on the image. That would help the process, but also the estimation engineer who may not have the vast experience of a shop floor worker on the systems that do, molding, grinding, milling, and so on and so forth. But he would be able to actually take the AI system and suggest him a primary manufacturing process from which the estimation process then goes on. So that's another use case. A further use case that we're seeing here is, and we see a screenshot down here of SEER. You may see that you suddenly come into a job where your organization has produced equipment that has traditional electronics. In the future, these devices in this given scenario may have embedded electronics, embedded computing device, embedded software to do some highly automated, maybe AI-driven work. Now, do you naturally have the skill to estimate that in your organization? Maybe not. In this case, what one could do is use a prompt that would actually get you the data from the public domain. And that could be data about structure, system structures, but it could also go down to the level of parameters. What are the amount of electronic boards into such a system? Is it 1 or is it 10? Maybe it's 2, 3, or 4, right? So the prompt will give you a reasonably good data set for you to do a first shot at the estimation exercise, although you don't have that information in your organization so far. So the graphic that you see here is a screenshot of SEER, where one of my colleagues has queried for a particular structure and he got the information back. He created a new knowledge base, which is now part of his knowledge and estimation asset going forward. This is a view into a concept, basically, of a product that Galorath has launched already 14 years ago. It's an AI-driven system based on the case-based reasoning concept, which is an AI concept itself. And it, in a nutshell, works with past data. You feed the requirement, you apply the expertise and the past experience from existing models, estimation models. And based on your selection of changed input criteria, such as changed requirements, you can actually do a new estimation just by clicking through the or reshaping the requirements that you have, right? So let's quickly click through. There's a list of different requirements that you can actually choose from. You have different choices for the different sets of requirements and categories of requirements. And from that, you basically create your advanced understanding of systems that you may not have knowledge about today. You only know, in this given scenario, about the requirements. And once you're done, you basically create a complete model that you can reuse in this case in SEER, from which you can actually leapfrog your estimation work by probably 80–85%, right? So this is also possible for estimation in software or estimation in IT, for IT projects. And IT projects quite often have significant similarities, and from there on, create a fairly fast forward type of estimation exercise in your journey. Okay, so that was the last of the last specific use case. I want to share one thought provocation, which is, I think it's spot on, basically. The more extensive a man's knowledge of what has been done, the greater will be his power of knowing what to do. So this was Benjamin Disraeli, a UK Prime Minister, more than 100, almost 200 years ago, 180 years ago. How wise of a conclusion was that? The knowledge that we have across different organizations, across different trades, across different fields of research is so vast nowadays that no one can know everything. So how great will it be if we are able to tap into this knowledge with tools such as AI? But then also, when I prepared this presentation, sometimes I got these nagging ideas and questions, how will it be? So in the future, talent acquisition, we know talent acquisition is hiring people, right? People to do certain jobs. And so now will talent acquisition also evaluate and recruit AI models and AI engines for a particular job in the future? Will that be the job enrichment for HR or talent acquisition? That's one question. Or now, if AI takes so much away from us in a positive sense, if we look at it from that perspective, so will our next generation have enough learning opportunities to become human, generally intelligent? Or are we just working on an abstract level and we don't know how to do the garden, and we don't know how to fix some basic problems? So I think that's an interesting question as well. Or should AI be able to say no? We're seeing some first advancement in that direction, but I believe AI should be able to say no to more than to more topics than breaching data privacy or IP laws. What's your thought? Now, looking to tomorrow, I think individually, it would be great if you take a playful kind of an approach to AI. AI has a lot of capabilities, and it's not very easy for an individual in an organization to do that within the organization. That may be related to IT restrictions, security restrictions, and so on. But playing with it in your private context can actually prime you for your next task in the company, or for your inputs for the next developments, how your organization prepares for the AI adoption. So it's easy, for example, to build Python programs with AI that helps you in data manipulation, right? If you have complex Excels with data patterns, there are tools out there that can help you with that, for which you need to be an expert on the tool itself. But even using Excel and an AI generated Python program, it can help you with that, right? Or you can actually hook up your Excel based with a generative AI system, and it helps you to query huge amounts of data for which you need answers for. So there are more of those. But basically, what I would suggest you going forward is take care of your data. Be strong in your organization to stand up for the adoption of AI and your organization preparing for embracing the opportunities with AI. It will make you much stronger. So with that, I am concluding the presentation, and I'm basically underlining again, you're at the steer, let AI be your assistant. Now, we're almost at the end of our session today. It first leaves me saying thank you. Thank you for your time and participation. But also, if you have questions, if you have any follow-up needs, etc., please write to seerinfo@galorath.com. We'll be happy to get back to you. Or if you would like to engage with the Society of Cost Engineers, you see the URL here, societyofcostengineers.com, and I'm sure Gary will be happy to support you with the organization at the back. So we now have accumulated an amount of questions. Let me quickly check.
So Fritz, I too am looking at the questions. Some of them are lengthy. One of the options is to type the answers in after the webinar, but I see you're looking at some of them. Any quick one, any that catch your attention?
So I would, for each of those, I would rather want to take an offline response. They're great questions, but at the core, I basically say, data is the key element. We can help organizations with the data preparation and the curation of data to feed into the systems, for example, into the case-based reasoning system, and enable you that way for the future and in the future. But correct, data validation is a question, validation and verification, and the use case that I've just shared will not take that problem away. It will still need to be someone who has an understanding about the viability and correctness of the data, not down to the last decimal, but is the response in the right ballpark? And then once you use the data in practical examples, it will give you then the learning curve from there on. I think just using public domain data is probably the wrong track. I think it will be an initial augmentation of knowledge gaps, but from there, I think it's important that you attend to the accuracy and learn from the data, in a kind of life cycle perspective.
Thank you, Fritz. This is Gary Kokens, a moderator. I'm one of the directors with the Society of Cost Engineers. There's one last question, brief answer from you, and then I'll have you do concluding remarks. I know we're running over. What has been one lesson learned by organizations that have been trying to implement or apply the things that you talked about during this webinar?
Yeah, so one very simple lesson is that organizations are, in most cases, not ready due to security reasons and data privacy reasons to just openly embrace AI. And the context that we're talking about today is the combination of enterprise AI and public AI, probably generative AI. So preparing the ground for that is a very important task, so that neither you can be, you are falling in the trap of doing wrong things in your organization, but also not exposing the organization to possible risks. So prepare the ground and engage with the right people in security and IT. And I think you will be off to a great journey. The second one, Gary, if you permit, is indeed the data preparation, right? So that case-based reasoning example that I shared, it was launched 14 years ago. Unfortunately, it didn't took off in the market. It was probably too early. But one of the reasons why we realized that it was too early was because you can only use it if you have good data in there, good past data. And that's an effort. Preparing data from which you can actually launch your next endeavor, your next estimation exercise, is a very important activity. So data preparation, I would say, is probably even more important than what I mentioned before. Thank you, Gary.
No, thank you, Fritz. And let me
Hey,
just
Gary.
give you
Gary,
a
this is
sneak-
Jerry Collins.
Go ahead, Jerry.
Fritz, I'm going to ask you questions that have come up, and I'm just going to ask you a question coming from a cost engineer's perspective. There's internal data and external data. So the internal data is the processes and the costs and everything that you know within your own factory or whatever. Those would be relatively easy to gather data and probably even verify, because that's what you've been using for your existence. How do you see collecting or just gathering data from processes in places that you don't control now? If I'm making a computer, I know how to make circuit boards or whatever. But if there's something that I don't know how to make, can I gather that kind of data? Or
Yes.
is that something that's going to be built into the estimation software?
So what we're seeing is clearly the possibility to ask questions from the public domain about logical dependencies, for example. So let's take an example. An organization ventures into the adoption of AI in the field of hyperautomation and in IT, right? So if an organization hasn't done that before, it will be a reasonably simple inquiry to the public domain and ask, what is AI ops? What's the benefit? What are the typical benefits of AI ops? And what are the numbers in quantitative numbers that have been experienced through the adoption of AI ops? So what you will get in return is a description of structures, a work breakdown structure related to AI ops, for example. You will get reasonably good information about typical benefits, even quantitative information. So that will be good enough for you to start a project based on a reasonably well-established footing for an AI ops project. Certainly, you will from there probably write a tender, you'll get quotes, you'll have a discussion, but it will bring you significantly higher in your elevation of your posture of knowledge compared to having nothing, right? I don't mean to say that specific process data, which goes down to the last quint, will be the right thing to inquire from the public domain, but topics such as logical dependencies, but even at a lower level, single parameters, very specific questions will be good enough to interrogate the public domain. There will be data points that will be consumed if the prompt is done correctly, there will be data points that come back from a distribution of samples that will be beneficial to you. That's a lengthy answer, Jerry.
Thanks so much.
Does it answer the question?
Yes, sir. Yes, sir.
Okay, and incidentally to the audience, Jerry Collins, who just piped in, he is actually the founder of the Society of Cost Engineers. So thanks, Jerry, for piping in. Fritz, as a sneak preview that your team may share with you, I've been looking at some of the evaluations, and there's a lot of thumbs up and great talk. So you apparently struck a chord with a substantial number of attendees. So I think we're pretty much concluding. I liked your quote from Benjamin Disraeli. I have a quote that I'll just share very briefly, and it's this. It takes 1 minute. It says that we believe that in the past, the best executives and best leaders had the best answers. Today, we don't think that's the case. Today, we think the best leaders and best executives have the best questions. There's too much complexity. There's too much volatility. There's too much uncertainty for them to rely on their gut feel or sixth sense or the types of answers they had earlier in their career that got them promoted to the top. They need to create a culture of investigation and discovery and tolerance for making mistakes as long as you learn from the mistakes. So I thought, Fritz, you and maybe the audience might enjoy that observation. So thank you very much. You have one concluding remark before we say goodbye?
I say thank you very much for your time and active participation. I wish you a lot of success in playing initially and then adopting for AI for your for the benefit in your particular role. Thank you. All the best.